Hi and welcome to Revise A-Levels, your guide to learning, revising, and succeeding at A-Levels. In today's topic, we will deep dive into binary prefixes, a crucial concept in computer science, especially for those preparing for the Cambridge A-Level Computer Science exam. Today, we'll unravel what binary prefixes are, why they matter, and how they differ from the more familiar denary prefixes. Whether you're a student or just curious about how computers measure data, this video will help clarify these essential terms. Let's start by understanding the basics of data measurement and why computers need special ways to count bytes. Before we dive in, let's acknowledge the experts behind this content. Robert Hampton, a seasoned computer science educator, wrote these notes, and James Woodhouse, another expert in the field, reviewed them. Their combined expertise ensures that the information you're about to learn is both accurate and up to date. Now, let's move forward and explore the world of prefixes in data measurement. Binary prefix is a unit prefix used to indicate multiples of bytes in binary. In simple terms, it helps us express large amounts of data in a way that aligns with how computers actually process information. For example, when you hear the term kilobyte, the kilo part is the prefix. Since bytes are the smallest unit of data a computer can store, we need prefixes to talk about larger quantities efficiently. Let's see how these prefixes work and why they're important. Most people are familiar with denary prefixes, which are based on the decimal or base 10 system. In this system, 1 kilobyte equals 1,000 bytes, 1 megabyte equals 1 million bytes, and so on. This method is straightforward because it follows the counting system we use every day. For example, a 1 GB hard drive can store 1x10 bytes. But is this the most accurate way to measure data in computers? Let's find out. Here's a quick reference for denary prefixes. 1 kilobyte 1 KB is 1000 bytes, 1 megabyte 1 MB is 1 million bytes, 1 gigabyte 1 GB is 1 billion bytes, 1 terabyte 1 TB is 1 trillion bytes, and 1 petabyte 1 PB is 1 quadrillion bytes. This system is widely used in marketing and product specifications, but it's not always the most precise for technical purposes. Denary system relies on the assumption that 1 kilo equals 1000, which is rooted in our base 10 number system. This makes calculations simple for humans, but computers don't operate in base 10. Instead, they use binary or base 2, which leads to some important differences when measuring data. Let's see how this impacts data storage and measurement. Computers use the binary or base 2 number system. This means that the denary system, while convenient, isn't technically accurate for describing computer storage. To be precise, we use binary prefixes, which are based on powers of 2. These prefixes help us express data sizes in a way that matches how computers actually store and process information. Let's look at the binary prefixes. 1 kilobyte 1 KB is 210 or 1024 bytes. 1 megabyte 1 MB is 220 or 1,048,576 bytes. 1 gigabyte 1 GB is 230 or 1,073,741,824 bytes. 1 terabyte 1 TB is 240 or 1,099,511,627,776 bytes. 1 petabyte 1 PB is 250 or 1 quadrillion 125,899,906,842,624 bytes. Notice how these numbers are slightly larger than their denary counterparts, reflecting the binary nature of computer storage. Key difference between denary and binary prefixes lies in the prefix itself. For example, kilo is used in the denary system while kibai is used in the binary system. This distinction helps avoid confusion and ensures that data measurements are precise, especially in technical contexts like computer memory and storage. You might wonder why these differences matter. The answer depends on how precise you need to be. For example, when identifying the total amount of memory RAM in a computer, accuracy is crucial, so binary prefixes are used. On the other hand, when describing storage space, a rough estimate is often acceptable, so denary prefixes are commonly used. When it comes to RAM, or random access memory, precision is essential. For example, 16 GB of RAM means the computer can store 16x 230 bytes of data, which equals 17,179,869,184 bytes. Using binary prefixes here ensures that there's no confusion about the actual capacity of the memory. For storage devices like hard drives or memory sticks, denary prefixes are often used. For example, a 16 GB memory stick can store 16x109 bytes of data, which is 16 billion bytes. While this isn't as precise as the binary system, it's usually sufficient for everyday use and marketing. To better understand the difference, imagine two memory sticks, one labeled 16 GB and the other 16 GB. Although they sound similar, the actual number of bytes they can store is different. This small difference can add up, especially when dealing with large amounts of data or multiple devices. Confusion between denary and binary prefixes often arises because manufacturers and marketers use denary prefixes for simplicity, while technical documentation and operating systems may use binary prefixes for precision. This can lead to discrepancies in reported storage sizes and actual usable space. To avoid confusion, always check the units used. If you see GB, it's likely denary, while GB indicates binary. Being aware of these differences can help you make better decisions when buying or using storage devices and ensure you understand exactly how much data you can store. For students taking the Cambridge A-Level Computer Science exam, understanding the difference between denary and binary prefixes is essential. Questions may ask you to convert between units or explain why binary prefixes are used in certain contexts. Mastering this topic will help you score higher and avoid common mistakes. Common mistake is assuming that 1 kilobyte always equals 1024 bytes. Remember, in the denary system, it's 1000 bytes, while in the binary system, it's 1024 bytes. Always pay attention to the context and the units being used to avoid errors in calculations or understanding. Let's quickly recap. Denary prefixes use base 10 and are common in marketing and everyday use. Binary prefixes use base 2 and are more precise for technical purposes. Knowing the difference helps you interpret data sizes correctly and prevents confusion, especially in exams or when purchasing storage devices. If you want to deepen your understanding, there are plenty of resources available. Joining communities like Save My Exams can connect you with over 100,000 students and give you access to more revision notes, practice questions, and expert guidance. Learning together makes mastering these concepts much easier. Now that you understand binary and denary prefixes, you're ready to tackle more advanced topics like number systems and data representation. Building a strong foundation in these basics will make future learning much smoother and more enjoyable. To sum up, binary prefixes are essential for accurately measuring and understanding data in computing. Knowing when to use denary or binary prefixes can help you avoid confusion, make better decisions, and excel in your studies. Keep practicing, stay curious, and you'll master these concepts in no time.